Jai Jindra, Namaste. My name is Sayam Jain. Welcome to my channel. Today we are going to solve the 22nd question of the problem solving series, which is based on arrays. So, for some problem. So, this question has been asked in multiple companies, as you can see, Amazon, Adobe, Microsoft, and many other companies. And the difficulty level for this question is medium. So, let's begin. So, for some problem, so we are given a array of numbers and we are given a value k. So we need to return or we need to print all the elements, array of elements whose sum is equivalent to the value k. For example, here k is 3, so we can see that the sum of 0, 0, 1 and 2 is 3. The other condition is all the elements whose sum is equal to 3, the array of those elements. The other array's element should not be the same. Means we need to return all the unique elements whose sum is equivalent to 3, equivalent to the value k. So in this example, the second example, we can see that these are the numbers and the value k is 23. So there are three unique values set of elements we have whose values are equivalent to 23 and they are unique. So here 2, 3, 8, 10. So 2, 3, 8, 10 is 23, 2, 4, 7, 10 is 23 and 3, 5, 7, 8 is 23. So this there is no repetition of the values, right? So in this way we need to solve this problem. This question is similar to the two-sum problem, famous two-sum problem that we have solved before, we have discussed before. But now it's a four-sum problem. So as we have discussed in the two-sum problem, we have solved the two-sum problem using multiple approaches. We have solved it using two-pointer problem, we have solved it using hashing. So how do we solve this? Are we going to use the same concept that we have used in two-sum problem? Yes, we will have to, but let's discuss the approaches for this problem. So what is the brute force approach? We know we can just fix a value and then keep on going to the other value and see whether the sum becomes 3 or not. So in that case, the brute force approach, we can solve it in order of n to the power 4 because we need to find 4 sums. For example, means a sum of 4 elements, right? So here for 0, 0, 2, 1, we need 4 elements. The sum of any 2 elements is also 3, but we need 4 elements and those 4 elements sum should be 3. So like suppose we fix this 0 and then this 0 and this one as well, and then we can move this, right? In that way we will find it. So again we need to move ahead and we need to do this. We have done this kind of problems a lot. So in that way we will get all the elements and the elements will be unique as well, right? It won't repeat because we are not going to repeat it, right? So in the brute force approach we can solve the problem in n to the power 4 time complexity. How do we make it better? If this was a two-sum problem, we have solved it using a two-pointer technique, but we need 4 such elements, so sum should be equal to k. So we can actually do it, we can reduce one loop, we can fix 2 elements and the other 2 elements we will use and we'll use our two-sum technique, right? Using 2 pointers, we can solve it. This discussion, you can check my two-sum problem question and see how we have solved it. So in that way if we do it, so we have fixed 2 values and then we are finding the other 2 values with 2-pointer problem. So in that way a better approach would give a better approach and the time complexity would reduce from n to the power 4 to n to the power 3 using 2-pointer plus fixing this thing, brute force, 2-pointer plus brute force. But can we do it better? Yes, we can. We will be using hashing now. Now how do we use hashing? We have used hashing when it was a two-sum problem, but now we have 4-sum problem. So any idea what we will be doing? Let's give discuss the idea and then we'll go to the solution. So now we need 4 such elements to give us a value. Like here we have 23 and we need to find 4 elements whose sum is equivalent to 23 and those values should be unique as well. So suppose into some problem what we were doing, we were storing the elements in the map, and then we were searching for the sum that we need, k minus the element that we have. Like for example 23, we were storing all the elements over here. If suppose this was a two sum question and we had this, the k as equal to 15, right? So what we used to do, we used to store all these elements and we used to search 15 minus 10. Is 5 present over here or not? And we knew that this 5 is there in the map. So we understood that this 10 and 5 are the numbers whose sum is equivalent to 15. But now we need 4 such elements. So can we store the sum of all 2 elements and then search for the k minus the sum of those all pairs? Then will we get the other 2 pairs? Am I clear? So let's think what I mean to say. If we use a double loop and we store, we take a map structure and we store all the pair sum, right? So now we have all the pair sums like 10 2, 10 3, every pair of sums we have, and we know what are the indexes of those sums. Now again we traverse this array and we find k minus the pair of sum that we have, and we see if it is present in our map, k minus that sum. That means we have got this sum. If the indexes that we get from the map are not the same indexes that the sum has, then we have got all the unique elements. Then we will store it, for example here, right? 2, 3, 8, 10. How these values would have come? Suppose we have stored all the sum in this map, all the possible 2 sums value, the sum of pairs we have in this map, okay? And we know what are the indexes of those, right? So suppose we are traversing it again now. Now what we have, 10 plus 2, 12. 23 minus 12 is 11, right? Is 11 present in the map? No, it might not have present. For example here, 2 and 3, these are the answer, right? So 2, 3, 8 and 10, right? Suppose this 2 plus 3 is 5. We search 23 minus 5, 18. Is 18 present in the map? 18 should be present in the map because 10 plus 8 sum is 18. So we will get that yes, 18 is present in the map. Then what we will do? We will see what are the index, because this map structure will actually have 23 comma the elements index value, that is say 0 and 0, 1, 2, 3, 4, 5, 6. 0 and 6, right? So we saw that this 23 is present, and then we see what are the indexes whose sum has given 23. So 0 and 6 were the indexes whose sum is actually not 23, 18, because we were searching for 2 plus 3, 23 minus 5, right? Now what we will do, we will see that this index is 1, this index is 2. This 1, is it equal to 0 or 6? It's not equal to 0, it's not equal to 6. 2 is not equal to 0, 2 is not equal to 6. That means they are unique. They have not, we have not repeated it. 2, we have not taken it twice. So this is a unique set of elements whose sum is equal to 23. In this way we will get all the unique pairs, unique not pairs, unique number of elements whose sum is equivalent to 23. And with double traversal of the loop and this map data structure, we can solve the problem in order of n square. So let's code it. We will have we'll take a map, unordered map, int, and then pair of int comma int, say MP, and we have n is equal to array ka size, and then what we do, we store all the sum for I equal to 0 to n minus 1, for j equal to I plus 1 to n, right? Yeah, n minus 1. What we do, we add MP array of I plus j is equal to the I comma j, right? And then we close this. We have stored all the sum. Now what we do, we again repeat this thing for I equal to 0 to n minus 1, for j equal to I plus 1 to n minus 1. What we do now, we see if the two sum logic, that if the sum is NP, okay, int sum array I plus array j, okay, we have got the sum. If this k minus sum is not equal to mp dot n, that means it is present in the map. That means we have got the numbers, right? Here we will see if it is present, that means what? We have pair of numbers, pair of int comma int p. We have pair is stored as it would be pair of int comma p would be mp of this value, right? mp of sum, this mp of k minus sum, right? Whatever the value is there. So if p dot first is not equal to I and p dot first is not equal to j, that means the index which is whose sum actually we are searching, and same for p dot second not equal to I and p dot second not equal to j, that means we have got our elements, and we can just see out the sums, array of I array of j, right? I will anyway solve it in the code run, and then mp of array of p dot first and mp of array of p dot second. We will print all the 4 unique elements, and with this whole double loop array of traversal, we will have our values printed. Since it is a void data type, we will be printing it over here. So in this way, we will be able to solve this problem. The link to the question has been given in the description. Please try to solve it yourself, and then please go to my code walkthrough section. Here is the code walkthrough section of the 20-second problem, the 4 sum question. Here it is four elements. So here we can see that we need to just return whether we have 4 elements or not, whose sum is equal to the given sum. For example, here you can see there are 6 elements and this is the array, and we need to find whether there are 4 elements whose sum is equal to 7 or not. So we can see 1, 5, 1, 0 are those elements, and the output is 1. So here we have discussed about finding all the elements or the unique elements. So we have just done the same coding what we have discussed here. We have this unordered map, and we are storing the pair, the sum, and the pair whose sum is equal to that sum. So all the pair sums we are storing over here in the map in this first part, and then we are traversing it again twice, double loop, and we are checking the sum, is that sum present in the map, and we are checking whether all the elements are distinguished elements or not. So if they are distinguished, it would obviously fall in this condition, and then we will be storing this into the array, and then we'll be sorting it. We can sort it so that if user wants here in this question we don't need it, but we can sort it, because if it in question is given that you need to return it in sorted order, and you need to return all the pairs whose sum is equal to the given sum, the 4 elements. So we can just return this answer vector, but where we just need to return whether it is possible or not. So we can just run this code. So the base test cases have passed. Let's submit this and see if it works. Yeah, so all the test cases have passed. Let me know in the comment section how was the explanation, and see you all soon in the next video where I'll be explaining the 23rd question. Jai Jindra.